Good morning, everyone. Welcome to this session on assets and infrastructure under the theme Health, Safety, Security, and Environment. We have six speakers in this session, and the first one is on long term continuous monitoring of methane emissions at oil and gas facility by Dr. David Rendell. He is a PhD from University on Bayesian statistics and has 13 years experience as a statistician and data scientist. I think let's hear him out. Methane emissions are a cause of concern, and they are one of the much more dangerous emissions compared to CO2 for the environment. So let's hear Dr. David. Please go ahead.
Hi, thank you everyone for inviting me to speak. Thank you to the chairman. Yes, I'm from Shell. I'm talking here about methane emissions. Methane is a highly potent greenhouse gas. It's roughly 30 times worse than CO2 as a greenhouse gas. So uh, in Shell, we've been looking into approaches to monitor and measure methane emissions. We have signed up to the OGMP 2.0 framework, which is a UN-backed voluntary framework around methane emissions. One of the key requirements for the OGMP framework is measurement of methanes, as opposed to the more engineering-based calculations that a lot of emissions are calculated from. So within the methane measurement technology space, there are four different methods. So this talk will focus mainly on continuous monitoring, but briefly, there are source level measurements generally done by handheld technologies. There are some satellite-based methods, and probably the most well used method right now for methane measurement is emission measurement is drone-based emissions. But we're going to look at continuous monitoring today. So within the world of continuous monitoring systems, there are various technologies. Um, Typically, it'd be some kind of network of sensors. So, for example, a bunch of point sensors, each measuring methane concentration. Um, but there are also laser beam technologies with optical reflectance, and they move around, and there are camera-based technologies. So we think some of the benefits of continuous monitoring are earlier detection than more campaign-based leak detection, and the ability to quantify time-varying emissions over time. So uh, historically, continuous monitoring technologies are not necessarily mature and widely used, and largely this is due to issues with detection thresholds and high false positive rates, um, but also the ability to sort of actually quantify those emissions and localize those emissions uh, in a continuous and easy to use way. Um, so in Shell, we've had some deployments of these sensor systems at various types of facilities, including sort of gas processing facilities with manned facilities, but also some unmanned facilities. We've deployed both these point sensor networks and open path beam sensors. Um, so one of the key gaps that we saw in Shell for deploying these technologies was how do people process the data that comes out of them. You end up with a lot of time series data, and trying to actually make sense of that is difficult. So we have developed something we call PyL, which is a method for detecting, locating, and quantifying emissions from this type of sensor data. And so it uses a gas dispersion model together with inversion methods to localize and quantify emissions. Um, that software has been open sourced, and the code is available. It can be found by Googling if you want it. But the reason we've decided to do that is we're trying to mature the technologies in this area. We're trying to improve sensor vendors' abilities to do this real-time data manipulation. But also we're trying to create a transparency and openness around how methane emissions are calculated and quantified, because we think that helps to support the efforts we're making in making measurements and make them more viable within this kind of a framework. And we're also trying to encourage further development in this area and make it a more sustainable technology. So we have done some tests in some various facilities, but there is a paper on this one, which is a gas processing facility in the Netherlands, and this uses a sensor by a company called Miraco. The sensor is in the bottom left corner. It is a beam sensing technology that will move around a site in a kind of radar fashion, looking at retroreflectors and measuring the average concentration along those gas facilities. So we've done 3 trials with these sensors now at these sorts of facilities, along with some controlled release experiments where we've released known concentrations of methane and tried to show we can re-get those methane emissions back. So some of the issues you get with this kind of data is there's all sorts of effects of localized methane concentration. We get strange peaks in data at night due to sort of temporal inversion effects, and we have to sort of handle all of that. So that's what the software that we produce does. The picture on the right shows a series of localized leaks that we found using this technology, and we have since gone and done surveys with more handheld instruments, FLIR cameras and the like, to basically verify that this is a sensible approach and that it actually demonstrates corresponds well with the emissions on site. And we were able to quantify down to around 5 kilograms an hour at this site. We also have a deployment at a site which was a drilling site. So this site has periodic drilling operations, in-well operations, and one of the real benefits of this kind of technology is the ability to show the change in methane emissions during the drilling operations. So the chart here shows cumulative emissions over a period of time, and there were 3 drilling operations, all of which had associated contributions of emissions. And there was also a surging event which led to an upturn in emissions for a decent period of time, which correspond to a disruption in well. Now, this kind of data basically wouldn't be possible to measure without a continuous monitoring system. Any kind of drone-based method or other sort of sensing methods would essentially only give you one point in time, and the likelihood is you would not be able to get lucky and measure on the right day to capture those kind of events. So we've also deployed these sensors at some gas processing facilities. This is a different sensor system by a vendor, the SUFI sensor by a company called ChampionX. So this data is used to kind of localize emissions. So sometimes with these kind of sensors, with the wind, you need the wind localization. The wind direction helps to localize the sources. So the data can be used to triangulate where things are. But yeah, depending on where the wind is, you can't always localize everything. But we use longer times to hopefully get the wind to move around, and then you get an ability to quantify stuff given enough time. Um, so um, yeah, so um, yeah, this is a picture of some of the leaks we found on this site, which again corresponded well to the facilities. But there's also a picture on the left-hand side there, which shows what we call a concentration rose, as opposed to a wind rose. But what it shows is for each sensor, the wind direction at the time of the for each concentration. So where you see peaks there, that basically is showing the direction from that sensor towards probably high leaks. So that gives you a sense of the sort of triangulation that we do to then localize emissions. If you know where the sensor is, you know where the wind direction is, you can basically localize things relatively well. Um, so yeah, so in conclusion, yeah, continuous monitoring technologies, we think they have a potential benefit in terms of early detection of leaks, and in the world of the quantification of time varying sources, and we can have a confirmation of leaks, or even a confirmation of a lack of leaks, that is quite difficult to demonstrate any other way. However, there's still remains open challenges in actually demonstrating and maturing the cost of these kind of solutions. So we hope to continue developing those over the next few years. Larger emissions are relatively easy to detect with these methods, but the actual thresholds depends on the sensor and the exact technology in in uh, being used, right? Um, so yeah, demonstrating true positive rates and avoiding too many false positives is one of the key uh, needs for any kind of data analysis that gets used. Otherwise, people lose faith in these kind of methods, because if you're triggering alarms for leaks every 5 minutes, then you lose all credibility in terms of controlling or reporting these data. But having long-term data can also be helped to improve the accuracy of these methods and develop them further. And lastly, lots of people measure concentrations, but concentrations are not necessarily emissions, because there is background emissions and there is variability in background emissions. So yeah, when we do these inversions, you've got to make sure that you understand how the background variability happens to be able to discount its effects. Yeah, a couple of acknowledgements of some of the sensor providers and collaborators in Shell. Yeah, that's it from me.
Thank you, Dr. David. And methane emissions, all of us know, is a cause of concern as far as GHG gases emissions are concerned. And fugitive emissions, finding where the location and the rates of release is a challenge for gas processing plants, drilling sites, and refineries. And a good solution using Bayesian method to find locations and rate of release that you've worked on is a very interesting topic to everyone. So I now request V. Kamesh Jain, AGM R&D uh, from EAN, to give his presentation on solutions for reduction of
Good morning,
sulfur
everyone.
dioxide emissions. Please go ahead.
Good morning, everyone. Uh, this presentation is made specifically to bring you a few points wherein we can identify the energy saving areas in the unit related to sulfur recovery, tail gas treating, amine treating, this sulfur block area. And that we have tried to bring few case studies which we came across while we are executing few projects, and these case studies were taken the direction to show you the quantum of energy that we can save, and what are the problems because of which the energy is being lost, and what solutions we have provided to mitigate that energy loss. So this presentation has got two parts. The first part is about the EIL technology portfolio in the area of sulfur block, and the second part is the case studies. So this slide, I would like to show you the capabilities of EIL in the sulfur block. So we have the expertise and the technologies in the area of amine regeneration, sour water stripper, SRU including TGTU, amine purification, ammonia recovery to produce aqueous and anhydrous ammonia, and associated upstream and downstream utilities and other areas. So we have did good number of projects in this area. So we have got multiple project experiences in conventional sulfur recovery unit, tail gas treating unit, oxygen enrichment we have done to increase the capacity of sulfur recovery units, and we have got a cat gas technology to remove the H2S from liquid sulfur. We got amine purification technology which we have recently developed, and we are also commercializing this. We have got technology named as CatSol, which is used to remove the H2S from gas processing streams, the streams which have got H2S, very lean H2S concentrations, maybe less than 1% volume. So that also we have demonstrated in some of the Indian gas processing complexes. So with this comprehensive technology and execution experience that we have got, we have did energy optimization studies for many refineries. So typically the method which we adopt while we address the energy studies or energy minimization case studies is like we try to rationalize the equipments and upgrade the facilities. Like if we got a few extra equipment, so how to minimize those extra equipments, and how to adopt new technologies. That is also a part of the energy case study that we do. Heat integration, this is a very important thing that we consider while we do the energy audit. Optimization of process parameters, like suppose if we have got a reactor which was designed maybe 15 years before, so the inlet temperatures may be in a higher side. So if we got a better catalyst, so obviously we can reduce the inlet temperatures, so that will result in a overall saving of the in terms of OPEX. After the steam and power, so we definitely concentrate on the steam and power while we do the energy audit. So this is a kind of a pie diagram wherein we would like to bring the different units in a refinery and what potential they have got while contributing for the total energy loss minimization. This we have done for 15 PSU refineries, and this is a summary of that results. So we can see now the area of interest is sulfur block. It is contributing, it has got a potential to reduce 8% of the energy, we can reduce that energy loss. And we can see the primary units, MS block, secondary units, bottom processing, treating units, hydrogen management, steam and power network, and utilities and offsites. So while we did the energy audit, we have considered all these areas, and we have identified the potentials. And in the sulfur block, it is 8% is corresponding to somewhere around 0.166 million tons of oil equivalent. So now we will be discussing the energy loss in the terms of tons of oil. How many tons of oil I can save? So 1 ton of oil can produce around some 3.1 tons of carbon dioxide. So that is the potential for decarbonization. So this is the first case study wherein we have given a asset. So we have got some 5 SRUs of different capacities. So we have told them that by adopting the oxygen enrichment technology, and by reducing the operating conditions of a few equipments, we can save a quantum of energy in the range of 12,000 metric tons of oil per annum. So you can imagine how much amount of CO2 production we can reduce. So this proposition was accepted by the client, and multiple projects we have executed while reducing the while increasing the capacity of the SRU, and also optimizing the assets. So I request people to look in this area if you have got any excess or surplus, units in the under operation. So obviously we can try to minimize that energy loss through rationalization of the units. The second area that we found by an accident, not we were not concentrating upon the heat loss, but through some other requirement, we were studying what was the reason for the loss in the temperature in the main combustion chamber. This is one of the very important equipment in the sulfur recovery unit. So we came to know by observing the trends of the thermocouples, skin thermocouples, and we came to know that the temperature of the skin on the shell was in an increasing trend over a period of time. That we have identified the quantum of heat loss that has happened and how to reduce that heat loss. That summary solution was provided to the client. But here for this conference, I thought that we will bring this in a different manner. So the quantum of energy that we can save by observing the skin temperatures is in the range of 30 tons per annum. This is for a sulfur recovery unit having a capacity less than 20 tons per day. So imagine if a sulfur recovery unit having in the range of capacity in the range of 200 tons per day. So if we can identify the skin temperatures profile itself, we can save huge amount of energy. That energy would have been converted into steam, which will be sent to the steam network. So I found that mostly this part is being neglected because of awareness is not there. So that I would like to bring forward in this conference. There is a troubleshooting case study that we have done for one of the refinery. There they were unable to operate the SRU after shutdown activity because of they don't know the reason actually. So there were multiple issues in operating the SRU. So we did a holistic case study, and we came to know that there is a catalyst channeling which is happening in the converter, because we cannot open the converter. So we need to prove that through the simulation and through the other parameters, and cross checking, and that kind of experience we brought in. So the client has accepted, and we have opened the reactor, and we have arrested that, shown that there is a this is the area wherein the leakage is happening, the slippage of that the process gas is bypassing the catalyst. So because of this, there is a very important thing that the sulfur dioxide which is slipping through the reactor is consuming the hydrogen, and that is amounting to somewhere around 300 tons of oil per annum. It's a huge amount that they are not aware. So simply by monitoring the analyzers and that process parameters, we can bring in the efficiency within the equipments. And this is a technology that we have developed to recover the ammonia from the sour water stripper gases. Currently, these sour water stripper gases are being routed to the sulfur recovery unit to burn the ammonia into nitrogen and water vapor. So we gave a proposition to convert that, to recover that ammonia in a useful form. So that in fertilizers we are producing the ammonia from the natural gas, and here in refineries we are burning the ammonia into nitrogen and water vapor. So we thought that we can plug these two, and that ammonia can be recovered in two useful forms. One is the aqueous ammonia and one is the anhydrous ammonia. So the aqueous ammonia, we are already establishing a plant in one of our Indian refineries. So the quantum of energy that we can save by producing 4 tons of ammonia per day is around 65 tons of oil, plus additional savings in the sulfur recovery units, which we have not quantified, because this is a huge savings are there. So this is a very good value proposition to any customer who like to bring the capacity, more capacity in the sulfur recovery unit, and at the same time convert waste into valuable products and have a byproduct which is a useful form which can be marketable. And the last case study is this amine purification. This is a theoretical case study, even though we are giving a plant in one of the Indian refinery. It's a theoretical case study. We thought that we will do a simulation and basing on the actual flow rate, how much energy we can save by considering all the possible options and all the possible OPEX involved in it. So we can save somewhere around 50 MTOEs per annum. So exactly what is this amine purification is that it removes the heat stable salts. The heat stable salts are tied up with the amine, so that amount of amine is not there to remove the H2S or CO2. So we will have to put more amount of amine and more circulation. That circulation will result in more amount of reboiler heat duty. That is coming to somewhere around 50 MTOEs per annum, which is for 6 meter cube per hour of the flow rate of amine. So if we have got a higher capacity, obviously the savings will be huge. So in summary, EL is continuously upgrading its technology portfolio with respect to ensuring that the technologies that we provide meet the energy specific and reduce the specific energy consumptions, because we are participating in a competitive bidding, and we have developed a few technologies like ammonia recovery, which converts waste to value, amine purification, oxygen enrichment, because oxygen enrichment not only it has got a potential to increase the capacity of the SRU, but also it has got a potential to reduce the overall OPEX and bring the reduction of the CO2 emission. And we would advise our refiners to follow the design, monitor the parameters, prevent losses, maintain equipment health, regular audit, adopt new technologies, train personnel, consider waste value. Thank you very much.
Thank you, Kamesh. That was decarbonization of sulfur block potential. Various methods like oxygen enrichment of SRU, reduction in the heat loss, troubleshooting, and waste to value. I think you presented some good solutions. Most of oil industry in India have committed to net zero, at least in scope 1 and scope 2 emissions. And your solutions will be very useful for the refineries, which are the maximum, they contribute maximum to for scope 1 and scope 2 emissions. I think it will help all of them. Thank you. Now we have Anjali Bala from ONGC. Uh, she is going to talk about, are we ready for being taken hostage, navigating the complexities and challenges in adopting AI and ML for security management. She's a unique professional in the sense that she comes from biotechnology background, and she has a proven track record in industrial and internal security management, both government and corporate sector. Over to you.
Good afternoon, sir. Thank you, Chairman, sir, for giving me an opportunity, and thank you, organizers, for this platform. I am Anjali. I'm working at corporate headquarters at ONGC, and earlier I worked in the government sector and then transitioned to the corporate world, looking after the security management. Today, I'll be talking about the challenges and complexity of AI and ML in security management, particularly in the oil and gas sector. So, as we are primarily dealing in the energy industry, so we know its importance, how it's energy that is powering our homes, our transportations, our communication systems, and everything. For it's important for the national security point of view that in case of any conflict related to security, that first thing that comes to our mind is the securing of the critical energy infrastructure. So we have seen that in case of the Russia-Ukraine crisis, the cases of Nord Stream explosions or the attacks on the Iranian oil refineries. So the terms energy and security are so intertwined that the concept of energy security has become the prime focus of the sovereign nations nowadays. So, how do we ensure that the criticality of this infrastructure? So, for that, we protect our critical energy infrastructures, or we keep the backup. The concept of strategic reserves is a part of that mitigation strategy. The other one is the protecting of the physical security management of our critical infrastructures, so where traditionally it has been done with the human intervention and the surveillance and monitoring. But now it's undergoing a complete transformation because of the concept of introduction of the artificial intelligence and machine learning in the management systems. It's the AI and ML in the security management or in the any other system. It's not just a buzzword in the tech world anymore. It's transforming every aspects of our life, and security management is not exception to that. Uh, at a time when everybody is talking about or joining this revolution or integrating it in our systems, because it has so many benefits. Uh, it has the capability of handling a vast amount of data, and it uses that data for predictive analysis, for threat predictions, and plus it's had the ability to learn from instances, as well as how the training is going to be done for the training models. But we cannot just rely on the benefits of the this system, because although there are several facets of this, we have the ZTA concept in that, where the AI models are met with the suspect that whatever decisions they take, it's not accurate, or it's not what it used to be, because this transformation is always fraught with its own challenges, like the challenges of its bias in the training models, the how it's integrated with the existing systems, and these bias are actual in nature and very real. Like we heard our honorable prime minister yesterday when he was speaking at the AI Action Summit, where he gave a simple example that if you ask an AI model to draw a person writing with the left hand, it will give you back a drawing which only with the person who is writing with the right hand. So this is training bias is models are biased because it has been put on those data which are actually very limited and not diverse in natures. So there is a German proverb that we call "Befehl ist Befehl," that means an order is an order. It was used in the Nuremberg trials, mostly in the aftermath of World War II, where it says that any questionable action, when you try to justify it by the rules or by the laws or by a superior authority, it's just an attempt. So AI models are only an extension of that concept. So it has very little transparency, which has led to the black box problems. The decision making process is quite opaque. It can work in a operational system or in a process platforms or in a refineries or the different sectors. But security is a area where even a 1% bias or even a 1% chance, we cannot take it, can lead to a serious consequences. We have different models of AI systems which have been procured from different parts, and when it is integrated in our entire ecosystem, the chain is even the chain is broken at single point. It can affect the entire network. If the input is manipulated even at a single point, the complete outcome of that system can be changed. We can have unidentified access to our systems, our workplaces, our installations, in every aspect of that. The major concern regarding the use of artificial intelligence in security system has come from in the form of privacy issues or the human right concerns. In most part of the, I will not say most part, in some part of the world, the governments are tracking their citizens and by facial recognition system, and linking that data to view the social credit scores. it has led to the severe human right concerns that it's not done with the consent of the concerned user or the population. Uh, One AI model, they used the social media profiles of the people, which was available publicly, to train their AI models. Which, when the backlash happened, they had to take down their process. The over dependence on automation, because security or the any system, it's has to be seen as a force multiplier, not just any system where you can just completely like we are seeing that it's going to replace the human manpower or the human intervention. It's not possible in any sense. It has to be seen in the form of an integration or an extension of the human expertise, or whatever we perform in our duties in human, and it could be an extension of the human intelligence, but it cannot be a replacement of the human expertise for any system. The use of this artificial intelligence has several consequences for our military warfare or for the security of our national assets or the critical infrastructures. Although these are not very commonly used, the lethal autonomous weapons, they are being on the cusp of being developed. Uh, uh, all the attack vectors, they are looking for the opportunities to look for, to use these in their own for their own benefit, because first they have very cost effective, they have a very little traceability, and they are very effective, still maintaining the lethality of the systems. The drones or the drone technology met with the AI power can have a very lethal consequences for the security of the system or the our national infrastructures. So some countries have developed it. South Korea has developed an AI powered sentry gun to along, and it has developed and deployed it across their borders with North Korea, where the guns, they track the any human movement and start firing without the human intervention. So it could be used for the military purposes or in that areas. But for our critical infrastructures, these systems are not very feasible because of the collateral damage that can happen and that it can provide. A very hypothetical situation was recently published, and a viral video on YouTube showed a, a post called Slaughterbot, in which they said a swarm of killer robots. They entered a British university hall, and they pursued, these drones pursued and targeted the particular individuals who had posted certain political comments on social media, because their social media accounts were linked, and these drones could specifically target the persons who had posted some objectionable content on their media accounts, social media accounts. They could be very well targeted. So they said, if in the same podcast, it was also it was a hypothetical situation, but it was also shown that there was a killer robot which was loaded with a payload of an voice recorder and a gun, and it could enter your home, and he just pointed the gun, and the voice recorder asked the person, or the target, to deposit certain amount in certain accounts. So these are the hypothetical situations, but it's becoming very real in the coming words. Like we had not heard 2 or 3 years back the concept of digital arrests and on, but now it's becoming, because it's happening with every two or third person that we know. In case of any breach, because these systems lack accountability, or they are very opaque in their decision making process, it becomes very difficult to account for any breach. Suppose in case of security breach or any breach in the system, we cannot held accountable a single person. Who should be held accountable? The company or the human operator who has designed the system, or the organization or the company who developed the AI system. It's not easy to provide, because even the guidelines are not there, the regulations are not there, and instructions are not clear to prove and hold anybody accountable for these systems. Although they have brought the concept of XAI, that is explainable AI, but still it's not going to cover the whole gamut of the complexity rising out of this situation. We have seen, although in exact military world or security, these things have not been used very frequently. Like we have seen the use of AI powered drones, and in the Israel Hamas concept extensively they have been used. But prior to that, they had the hackers could easily infiltrate in 2019. There was an incident where they could very easily infiltrate in the AI driven system, and they had manipulated the feeds of the cameras, and even managed to switch off that feeds. This same technique is being used to erase the traces of any breach if they without physically going into the field. It the same with the credit card system. It because of the bias in the training models, they used to give the lesser credit scores to the women compared to men with even with the same financial background. So uh, the it's a developing concept, but we need to trade this thing with a clear concept in our mind, that with while we want to use its benefits, at the same time we should not then oversight what it can cause, or what uh, consequences can have if we adopt it in our securing our infrastructures or our critical installations. The regulations will take time to come, but we cannot overrule the human expertise or the human intervention part while securing our infrastructures. The use of technology is welcome, and it should be done, but not at the cost of the compromising the overall national security or the security of the installations. So it's a very critical path where when everybody is going towards that, and you take a different turn, but you have to set your priorities and a balanced approach which can combine the power of this or the strength of the AI, as well as your own conscience and the human expertise. Thank you so much.
Thank you, Miss Anjali. You have rightly pointed out, considering the increasing use of AI in security management, balancing AI with human oversight. I think it's a need of the hour. Uh, we now have a presentation on by Abhishek Goswami, Deputy Chief Research Scientist, Oil India Limited, and he'll be talking on enhanced oil recovery using smart water prepared from treated produced water. All of us know that uh, enhanced oil recovery are methods used to increase oil production from reservoirs using treated water or different methods. So let us hear Mr. Goswami. Please go ahead.
Thank you, sir, and respected session chair, Murthy sir, and the audience present. So, uh, the work I'm going to present here is a laboratory work, basically, and on development of a smart water system for enhanced soil recovery from the sandstone reservoirs of Upper Assam. So here actually we are addressing two key issues when we are going to implement this in the field. We are going to two key environmental issues. These are use of less chemicals into our fields, and also handling of produced water, which is a concern for all the oil and gas operators, because we produce a lot of water along with the crude oil, and we have to handle that water carefully. So first, we want to discuss on the chemical part. Actually, we have to use a lot of chemicals in our oil and gas operations. These chemicals might be drilling chemicals, like workover chemicals, or different flow assurance chemicals, demulsifiers, and also some of the chemicals used in EOR applications also. But some of the hazards are associated with these chemicals. These are basically environmental hazards because of exposure to the environment, and also to the crew in operation. And accidental spillage might also risk the soil and water bodies present nearby, and impacting the aquatic animals living there also. But in our approach we are going to discuss, we are using very less amount of chemicals, and we are not using any exotic chemicals there. Another issue we have to deal with constantly, that is production of water along with crude oil. So what we do with the water, we actually first treat it uh, in our effluent treatment plant to eliminate the oil content, and then we also remove the suspended solids, and then we dispose it at certain depths into in the subsurface, so that it does not contaminate the drinking water zone. Alternatively, we also use these waters in other applications, like we can use it for produced water reinjection, for pressure maintenance into our reservoirs, and also we making the chemical EOR formulations. This water can be used for swag and wag treatments for enhanced oil recovery. These are water alternating gas and simultaneous water alternating gas. So in these kind of applications also we can use the treated produced water. And finally we can use it for smart water flooding. That is, smart water is it is recently actually for last in 1 or 2 decades it has come up, and it is basically ionic modification of the injection water, and thereby trying to increase the recovery factor of the oil reservoirs by wettability change mechanism. So what we do in the smart water flooding is a schematic, simple schematic is shown here. When we produce the crude oil, we, as I have already told, we produce water also. That water is first separated from the crude oil in the surface separator systems, and that water is treated in effluent treatment plant to reduce the oil content to some minimum level, and then to eliminate the suspended solid also. And then that water is mixed, that water is manipulated with the ionic composition in mixing tanks for smart water preparation, and it is injected into the reservoir back through the injector wells to get more production. So this is the basic concept of smart water flooding. So actually we are right now living in a very critical juncture due to the threats coming from the climate change. So we are constantly having these extreme weather events. So we have to move forward very cautiously while harnessing energy from our resources, and also keeping right balance by protecting our environment. So it can be done in several ways. One of the present thrust is actually on renewables, but we all know that renewables, although it is coming up, but it has not come up in a commercial scale globally. So for the interim period, we have to rely on the fossil fuels itself, but we cannot be encouraged for aggressive drillings in geologically vulnerable areas also, because that may further aggravate the climate change scenario. So in that case, URIOR is a very good option to, produce from our brown fields or matured fields, so that we can continue to produce from these fields, and alongside does not harm the environment also by adopting green UR methods. See, so this is one of the green environments, green UR methods, because we are not using any excessive chemicals here. So smart water flooding, we are discussing here. Smart water flooding is basically simple manipulation of the ionic environment of the injection water, and is using very less amount of chemicals. So there is no any risk of spillage, etc., and environmental exposure of chemicals also. And the chemicals we are using also, these are very common salts, so which are normally present in the earth crust itself. And the implementation part is also very simple for smart water flooding. We don't have to change the present surface facilities for water injection. We just have to modify it slightly, then we can go for this kind of implementations. And finally it has no environmental effect as such. So smart water is basically simple manipulation of ionic configuration, ionic change of the composition, as well as ionic strength of the different ions. So actually what happens, the sandstone rock surfaces are basically water weight. Water weight means these have more affinity for the water, and they allow the oil to pass through the pores for getting produced. But over a period of time, when we produce for a longer time from a reservoir, the reservoir rocks tends to become oil weight because they have a tendency to absorb certain components of the oil, which are, I mean, polarized fraction of the oil, because of the ionic parts of the formation water, divalent cations, which get absorbed onto these surfaces, which I am coming in these subsequent slides, the mechanistic details. As I have said, the sandstone surfaces are itself negatively charged, as well as the clay sites which are present in the sandstone surfaces. These are negatively charged, and they can absorb divalent cations onto it. And when we produce for a long time from a reservoir, the crude oil components which are polarized fractions due to presence of nitrogen and oxygen atoms get absorbed onto these rock surfaces through these divalent cations, and the rock surfaces become oil weight, which is not a favorable condition for oil recovery. But when we inject smart water with more divalent cations, the divalent cations tend to exert repulsive forces on the divalent cations already absorbed, and they just help to get detach these divalent cations along with the crude oil. So ultimately, the rock surfaces become water weight again, which is our desired condition. Because by that, by achieving that condition, we can get more oil recovery. In case of injecting smart water with negatively charged sulfate ions, here also the sulfate ions actually form more strong bonds with the divalent cations already absorbed onto the clay surfaces, and they tend to liberate the organic components which were absorbed on the rock surfaces through the divalent cations already absorbed. So ultimately, because of the incoming injection water which have more sulfate ions or negative ions, the crude oil components get dissolved, and water reservoir rock became water weight. So this is the mechanism which we are discussing. So in our approach, we use the sulfate and magnesium ions for preparing the smart water systems, and we assess the wettability condition by doing contact angle measurements. So we have prepared different some smart water systems, and the results are shown in the right hand side. In case of 500 ppm of sulfate and 500 ppm of magnesium, that is smart water ETP3 and smart water ETP4, we got maximum reduction in contact angle, that is maximum wettability reversal. And since the concentration for magnesium and sulfate are same, we use the one smart water system where both the 500 ppm magnesium and sulfate were added combinedly by adding 500 ppm magnesium sulfate. That was termed as smart water ETP5. So these are the results with high asphaltenic crude oil. We get reduction in contact angle from the initial value to the final value. The left hand side pictures are directly captured from the contact angle measurement experiments, where here we can see how contact angle has been reduced from the final value to the initial value to the final value. And we also compared it with low salinity water, because low salinity water is another technique normally used in water flooding techniques for more oil recovery. But here we can see that with our smart water system, we got more reduction in contact angle than even the low salinity water. And we also did experiments with normal crude oil, also normal light crude oil. Here also we got reduction in contact angle from the initial to the final value, and even better than the low salinity water also. So we did core flood experiments to get the actual validation of the wettability changes, whether we could get additional recovery or not. The core flood experiments were done by flooding with first situating the reservoir cores with formation brine, then flooding with oil to get the oil saturation, then displacing the oil with first ETP water, then with smart waters we have prepared. In all the 11 core flood experiments we have carried out, we got additional recovery. And in some of the core flood experiments, we in the intermediate stage we use low salinity also to get the comparison better. And after the low salinity also we get additional recovery in some of the experiments. And when we did not use low saline, we get more additional recovery. So now general observations are that in case of all the core flood experiments, we got additional recovery over and above ETP water flood, which is our normal water injection water. And in case of high asphaltenic crude oil, since the ETP water flood recovery is comparatively lower, so we got more recovery in by smart water flooding. And so in case of high asphaltenic crude oil, the effect of smart water is more noticeable in comparison to normal light crude oil, where the ETP water flood recovery itself is very high. So smart water is not giving that much recovery in comparison to high asphaltenic crude oil. So conclusion is that the wettability reversal was there with the smart water systems we have prepared, and we accordingly we have got the results in core flood experiments also. In high asphaltenic crude oil, as I have said, we have got better recovery in comparison to normal light oil. And most importantly, the effect is very environment friendly because we are getting dual benefit. We are gaining additional recovery with the benefit of water handling as well, and also we are not using excessive chemicals also. So with this I want to conclude, and thank you all.
Thank you, Mr. Abhishek. That was use of environmental friendly smart ionized water prepared from sodium sulfate and magnesium chloride for enhanced oil recovery. Thank you for the presentation. Now we have Mr. Ross Ferguson, is Regional HSC and Operations Manager, British Petroleum. He'll be talking about human performance and application of task improvement process.
Thank you, Mr. Chairman, for your warm welcome, and thank you, IEW, for allowing me to share BP's task improvement process. The task improvement process is one of BP's, as simple as that. Thank you, there we go. So what's human performance? Basically, human performance looks at the interaction between people, their plant and people, and the processes and procedures they use. It's key in human performance that we actually accept the human condition is that people will make mistakes. No system can be fully safeguarded, but we can look to understand where these mistakes can happen. In our high hazard industry, mistakes are obviously costly and tragic at times. So BP's internal incident investigation analysis correlates with the OIGP global analysis, where it shows that where human performance contributes to incidents, typically the people involved, their actions are not malicious, and typically the people's actions at the time make perfect sense to them. We have learned that these mistakes are typically due to causal factors, due to systems, and also the conditions that are in place at the time. These causal factors are what influence people and the mistakes that they make, and the task improvement process is a proactive tool to help us understand these performance improving factors and hopefully help us identify the ways we can prevent the mistakes or mitigate their consequence. So BP is a member of IOGP. We have adopted IOPC's human performance principles and practices, and these identify that human conditions lead to people making mistakes. It's a key process in our human performance application. This helps us, the application of the TIP process helps us understand the influencing factors, helps us understand the opportunities to prevent or mitigate, and also helps us understand how we can actually set our people up for success, creating people-centered design of plant, people-centered design of process, people-centered design of procedures. But it's also important to stress our part in human performance. As leaders, the tone we set, the conditions we expect, the behaviours we encourage are really important as we strive to make sure that the conditions eliminate mistakes for our people. As James Reason had said, we cannot change the human condition, but we can definitely change the conditions that influence our people. So from my experience, especially from the Caspian Sea, working with BP, I can actually talk with quite conviction about the TIP process, where it actually helps us understand why mistakes happen, but also, more importantly, helps us identify the opportunities to improve the design of the tasks. I have witnessed where we've reduced the probability of mistakes occurring, where we've reduced or mitigated the consequences of the mistakes, and also made it encourage an environment of trust where it's easier to detect or recover when people do make mistakes. This has positively influenced safety performance, but definitely also provides a real benefit to your operating efficiency on that offshore facility that you see there. So BP developed TIP to simplify established industry practice around safety critical task analysis. It's basically designed for our frontline teams, and all you require to perform task improvement process is a good working knowledge of the task you apply. You do not require a psychologist, you do not require a human performance specialist. It's really operator centered, and I find it really easy to use. Apart from safeguarding safety critical tasks, what we also found was because it involved our front line, we actually made human performance a lot more accessible. And the consequence of that was it started to become part of the day-to-day thinking of our operating teams. So a simple tool helps people identify mistakes and hopefully prevent people coming to harm. Provides really practical steps for our operations colleagues to set them up for success. Adaptable, you can use it for a simple task, you can use it for a complex task. Very easy to use, it's cost efficient, time efficient because it can be built into your normal working processes. And what is interesting, the actual operations team actually started to use the techniques without actually thinking or naming the technique. It just became part of their day-to-day. So the overview of the process is about identifying your critical tasks. Really focus on those tasks that influence your process safety barriers, and your local risk management processes should help you understand or identify the tasks to these barriers. The key to understanding the task is really to engage your workforce, the relevant engineers, the relevant technical experts, but most importantly, the people who regularly perform the task. These are really best placed to explain how the task is performed and also explain where they think the mistakes could happen. But to do that as leaders, it is really great, important to create a psychologically safe space where people feel comfortable to challenge and point out the differences in the working practices and some of our expectations or assumptions when we write the procedures down. So breaking down the tasks into steps helps granularity. It really helps us determine where we interact with each other, people on our process, where we interact with the actual plant, where valves are located, for instance, and also how we interpret the procedure or the process. And it does actually help you understand how work is actually done, and allows you, especially if you've designed some of that process, to test the assumptions you have made. We found it really vital to walk down the job as a team, and understanding these steps, really making an understanding of the conditions that could change when you're actually performing the task. Environmental conditions, the difference between doing a task during daylight or night shift, understanding if a key member of your team is unavailable, and do you have enough capability to manage that lack of competence. And understanding these conditions that combine and complicate routine tasks really helped us understand these influencing factors and the opportunity to remove or fix. So the TIP process focuses on how the work actually happens. And again, I stress, you need to make sure that the team built off with the right build of the operators that do the task, the experts that understand how the task should be performed, the procedure owners, the procedure writers, and hopefully a facilitator to referee quite an honest conversation. But that honest conversation only occurs if the leaders, we actually make sure it's a safe place to raise and challenge some of our existing processes. Very simple to use. We typically started off using a help sheet that gave us some prompts, a worksheet to record our findings, and the relevant procedures and drawings to guide us in the task. We have evolved it now. We have a digital application which is a lot more easier to use, and that has been really well done. But again, I stress site leadership is really important to make this happen, and also make sure that we share across the shifts across the operational site. So we talk a lot about performance inflation factors, and these are seen to be the causal factors that influence human performance, and these make more mistakes more likely. The general rule: the more performance influencing factors are present in a task, the more likely that you will actually have a mistake. And the range is quite extensive, from communication. My last place I worked, it was a multinational team, so communication became really key. Different languages. You have probably detected my Scottish accent does not always aid clear communication. So how did we overcome that? When we present an unfamiliar or new situation, are we really sure that the risks and the procedures are adequate for those abnormal conditions? The procedures, the signs, the signals are really clear on what the key steps are and the consequence if you do not get the key step correct. Understanding the why really does help you make sure that you deliver the important, and also not to always focus on critical steps as being the ones that are exciting, the boring, the trivial, the repetitive, can also be really important to how you deliver your work safely. So, in brief summary, our tasking process is based on the human performance principles set out by IOGP. I would encourage you to use their websites if you want to explore. The principles are simple: that the human condition and error is normal. As leaders, blaming doesn't actually fix anything, and our context as leaders actually drives the behaviours of our workforce. And learning from mistakes, or learning using TIP proactively before mistakes, is vital to how we deliver. To reinforce the task improvement process, when we used it, or I have employed it, does help you safeguard safety critical tasks. But the unintended consequence was we just made it more accessible to our front line, human performance more accessible. And ultimately, that thinking actually became quite widespread in the day-to-day operations. It was like an evolution of our risk assessment processes, basically making sure our people were safe, and actually led to quite improved operational efficiency. So thank you very much for your attention today. I'm in the BP booth in Hall 2. Anybody wants to follow up on this conversation, I'd be delighted to catch you there. So thank you.
Thank you, Ross. That was an excellent presentation, and I think it's a challenge all HSE professionals in oil industry they face. We all have standard operating procedures, but this is one step ahead of that to improve human performance by task improvement process. How to make them more refined, and you also talked about effect of performance influencing factors and the likelihood of more mistakes, more PIFs and more mistakes. I think it's a very good concept, and I think it's a method TIP should be adopted by entire oil industry, I feel. Thank you for this, bringing this to this forum. The last presentation for this afternoon is on FKM tight joint implementation in domestic regulator by Akash Agrawal, Senior Manager Equipment LPG BPCL. We all know that maximum accidents happen in while use of domestic LPG cylinders in customer premises, and one of the key factors or key reasons is the failure of O-rings, LPG leaking through O-rings when a regulator is connected. Initially, these O-rings were meant only for a tight fit and not meant to prevent leakage of LPG. But over a period of time, this has become the big challenge, and we have continuously number of accidents happening in the houses. And there is a new solution that has come out. this FKM use of FKM rings. So in this presentation, we'll have Mr. TD Sabu, CEO of LERC. He'll introduce briefly, and then Akash Agrawal will take over. So I request both of you to come onto the stage.
Good afternoon, everyone. Uh, as the moderator rightly said, uh, domestic LPG accidents are a major source of uh, grief and loss of wealth, and obviously, apart from loss of life, loss of wealth as well to the public at large in India. And as you may be aware, the oil companies are operating a complaint helpline, which is called 1906, to which you are supposed to call whenever there is a leakage complaint. So whenever a domestic consumer, a household member, notices any leak, they are supposed to call up this 1906 helpline, and they do call the helpline. And you would find that more than 90% of the complaints which actually come to this helpline is regarding leakage, the o-ring leakage. The moment you connect a domestic pressure regulator onto a cylinder, it starts leaking. So the 90% of the complaints that comes to this 1906 helpline is with regard to that. This tight joint, which is actually a part of the domestic pressure regulator and not a part of the cylinder, is an endeavor, a step in that direction. We should be able to arrest all sorts of leakages uh, from the cylinder itself, which would result in a fire and accident and loss of life. So I don't know how many of you have actually looked at a domestic pressure regulator. In Delhi now, you mostly have piped natural gas. So I mean that DPR era might have gone. But in other parts of the country, apart from the metros, we still have DPRs in use, domestic pressure regulators. And if you actually reverse a domestic pressure regulator and look at the bottom part of it, you would find that there is something called a tight joint. Now, this tight joint is actually supposed to provide a tight joint between the valve and the regulator. It doesn't actually arrest leakages. That is not the purpose of that component. LERC, which is the LPG Equipment Research Center, which is a joint venture of Indian Oil, Bharat Petroleum, and Hindustan Petroleum, and which pioneers research into equipments related with LPG and even now PNG and even hydrogen now. So we have looked at this problem for some years now, and we have developed this a tight joint, which actually has a different design and a different material of construction. So this tight joint actually prevents leakages when the DPR is connected to a cylinder which has a defective o-ring, or even when the o-ring itself is missing. Now, if you actually look at it, I don't know, again, as I was saying, I don't know how many of you actually looked at a cylinder. Now, the bottom part of it is the SC valve, and the top part of the red part is the domestic pressure regulator. And the blue ring which you can see is the tight joint, where there used to be a black ring earlier. So this actually sits on the valve and provides a tight joint. Now, the tight joint of the domestic pressure regulator, as you can see, is a very critical component, and it actually provides the seal between the DPR and the SC valve. Uh, so I would not like to show that, be too big. So now what it actually does, it has now increased the surface area of contact between the DPR and the regulator, and it has already been approved by PESO, and it gives you a much more tighter seal, and it can withstand a pressure up to 17 kgs. Your normal LPG cylinder in a household has a pressure say around 5 to 6 kg. So this particular tight joint withstands a leakage up to 17 kg. And as of today, you have around 65 DPR manufacturers in India. They all procure these tight joints from the open market. I mean, anyone and everyone is making these tight joints. Any rubber manufacturer is making these tight joints, the old NBR tight joints. Now the new design tight joint is can only be procured from approved vendors of LERC. Currently there are just 4 to 5, but they have all been approved and the process has been verified and they have been approved by PESO as well. So these samples should pass the test requirements in LERC at in all stages. The shelf life, of course, depends on the life of the DPR. As far as the implementation is concerned, Mr. Akash will take over now. The oil industry has also already started implementing this, and he will explain about the details.
Thank you, sir. Thank you, Sabu sir. So we'll just come to see that now whatever the FKM that particular part which we have developed, so that FKM tight attachment that we have developed, that is developed now. Now we have to see that how we have to put it in your home, my home, and the people who are using the cylinders. So as on date, currently there are five total number of vendors who can do it. We are planning to make it more. Like if you see in the point number 5, that the uh, capacity of that particular reagent is around 45 k per day, which is around 1.35 cr. Now this is very less as compared to the total number of tight joints, or you can say that total number of cylinders that we are having, which is around in the range of around 35 to 40 cr. Now what we are thinking, by this June figure, it is around 4 crore per annum. But what we are thinking, by the next year, June of 2025, we can reach this number up to around 10 to 15 crore per annum. So that will make us sure to get in almost around some 35 to 40% of all the uh, cylinders that we are having in the market. Now the demand, like I have told in the last slide, if you see the all the three oil companies, the total demand is in the tune of around 32 cr. And if I'm like if every year we are buying the new DPRs also, that is around 2.5 cr. So in and all, if you combine that, that is the total having a capacity of around 34 to 35 crore DPR, that we need to use it to make sure that the new type of tight joint will be placed in that, to make sure that the leakage complaint and all will come down. So now that testing is done, now we have to see that how this tight joint is uh, practically used in different markets. So being India, being a vast country, we have selected different areas: north Meerut, south Bangalore and Madurai, Nasik in the west, and east in the Ranchi. There are some other cities also which we have planned. So basically, the flow of the doing this whole exercise in a planned manner. Firstly, we have seen that the distributors, which are having the maximum amount of complaints all over India, we have identified that people. Secondly, we need to train the people who will change that tight joint in the homes of the daily users. Plus, since it is a unique activity, we need to make the tool also, which I'll come to the next slide. Then the 1906, which is the toll free leakage number, that analysis we have done to make sure that the persons or the area where the maximum amount of complaints are there, I need to make them go away fast. And lastly, the particular area, it needs to be completed in 100% of the customers. It's not like that out of, let's say, 1 lakh customer, I am putting in only 50,000. I need to complete the full area to see that how much outcome is there in the real time scenario. Now this is the way where we have done the training in LERC. As on date, around 500 plus total number of mechanics, or the people who are coming in our home to give the cylinders, are trained by LERC. The training certificate is also given by LERC to make them equipped, and to make them believe, and to make them trained
to do this critical activity in our home, the hands-on training done in various areas in the cities, like I've told, is done practically, giving them each and every person sufficient time and effort, and to see tell them that what they're doing is how much it is useful for all. uh, Now, coming to the tools part, so if you can see in the left side, so the tools needs to be made from the scratch. So initially we made the LRC has made some basic tool, then we have come out to a different version, then the newer version, to make sure that the whole process done by the mechanics and all will be easy and will be fast. So, like if you see in the right side, these are the live images where that our mechanics are changing that particular tight joint on site in presence of customer, to show them that this thing is safe and secure. Like I'll come to the next part for the complaint part of it. So, like Sabu sir has mentioned, the maximum issues which we are facing in our homes, in where the leakage happened, is mainly due to the O-ring complaint. So, as a sample, though we have done for more than 20 plus different distributors, like these are the two distributors who are based out of Bangalore. Now, if you can see from the month wise for the past in the 23-24 financial year, the maximum complaints were related to the O-ring. Now, we have done the trials. We have covered around 50,000 plus customers in these two distributors, and I am very happy to tell you that after changing the new FKM tight joint, all the complaints dropped down by 90 percentage. So 90 is also, I am telling, a very conservative number. There was some area where they were not getting any complaints at all for particular O-ring complaints. So there has been a significant change in the safety aspect by using this FKM tight joint, and the trials has been covered. Now it has been done almost in the 8 to 10 cities. We are planning to make it even more pan India. So in order to ensure that the whole issue of safety which we are finding in our homes one day, or for this thing, for leakage, that can go away. So FKM tight joint, like it is made by LERC, having a increased surface area, better safety, and the leakage also comes down. And this is a patented product. It's not like that if any other vendor will simply copy and paste. It's a patented product, tried and tested, and that we hope it will be there in our homes in time to come. Thank you very much.
Thank you, Mr. Sabu and Akash. Uh, this is a need of the hour, and hopefully the number of domestic accidents come down. This is a serious cause of concern in the entire Indian LPG industry, in domestic accidents, and this will go a long way in reducing those accidents, I'm sure. So we have had interesting sessions, right from monitoring methane emissions to decarbonization in sulfur block, and human oversight over AI, use of AI, and enhanced oil recovery method using smart water, and human performance task improvement process, how our SOPs can be made better. I think we have learned from Mr. Ross. And finally, this last session on improving, last presentation on improving domestic regulator performance and reducing the leakages. I think all six interesting presentations we have had from diverse fields in oil industry. I thank all the speakers for their time and effort, and enriching this conference. I request all of you to give a big hand to our speakers.